Cameron?
Well, I'm really in for Grace. I've already taken the content.
Well, you're already done this. You're in geometry. You know more about this than I did. No, I don't believe that. Just the two of you right now?
Yes.
Looks that way.
Okay. Well, what I had proposed to do this afternoon is geometry is so broad, and these problems that are on the geometry test are so random in the way that they're put together and then the ideas that they pull from. My idea was just to go in and to pull some random problems out and look at the geometry concept that's involved in these problems and then see if we can move forward. Does that seem reasonable?
Yeah, that works.
Okay.
Okay.
Yeah.
All right, so what let's do with this one, we'll start with a simple one. By the way, has everybody got a calculator?
Does my phone count?
If you can, you really need an 84, but
Okay, give me just a second. I have it. Give me a second.
all right, go get it.
We're driving. We probably won't be on this call for the whole thing.
Oh, okay. Okay, that works.
But Grace said she's teaching over this kind of material right now, and
No, hush.
I've already passed my content, so we can observe.
Okay. Yeah.
Okay, I got it.
So we ready?
Yeah, we're good.
Okay, so and this one's a little bit of review about parallel lines. So when in this particular picture, we've got line L and line M, and we know that L and M are parallel lines.
Mhm.
Now, we have these two women. I think
It's really bad.
yeah. Okay, we're good. All right, we got
It's probably just on mobile.
this angle right here is 2x plus 65. This angle down here is 3x plus 35, which you already saw a while ago. Now, what do we know about, well, the question is, how big is this angle?
Isn't it the same as the 2x plus 65?
Yes, but 2x 65 is not a degree measure.
Okay.
No.
So what do we know? It is, you're right, these two are vertical angles.
Right.
That's what we call these vertical angles. But what's this angle and this angle?
Or alternate exterior.
They're alternate exterior angles. So we know these two are vertical. This one and this one are alternate interior. And these are alternate interior. But these alternate exterior angles, what do we know about those two alternate exterior angles?
Equal to 180?
They're equal to each other.
I'm saying they're equal to each other.
Oh, okay.
So if we got that, then we can say that 2x plus 65 is equal to 3x plus 35. By that.
So then
So-
you just subtract 35 from one side and subtract 2x from the other side, and it'll be x equals 30.
Okay. So if we subtract 2x, then we get x 35, and we get 30. So x is 30 degrees. So
I'm allowed to be wrong.
2 times what?
30.
Plus
Okay. I can't figure it out.
that's 60 plus 65 then becomes
125.
Yeah.
125, I'm sorry.
yep. Easy enough.
Yes.
Okay. That's a simple start.
Okay.
So, I need to erase this because I need to draw some other kinds of things. So parallel, you see lines. This is a direct question right out of one of the practice test on there. Now, this next one is a little more interesting. And it involves two right triangles. Okay, so we know this is a right triangle, and this is B and C. All right. Now I draw an altitude up here and call it D. So we know that that's the right angle.
All right.
Okay.
Are we good?
Yes.
We're good. We have to. Grace and I have to go now, but y'all are good.
Oh, okay. All right. Well, have fun.
Dr. Watson.
All right. Now here's the deal with this one. All right. You've got CD. We know that CD is an altitude. So what does an altitude do?
I don't know. I'm not good at geometry.
Okay. An altitude is a line from the opposite side perpendicular over here. So
Okay.
altitude means that we form a right angle.
Okay.
Okay. Now we already know that this is a right angle because we started out with triangle ABC
Right.
as a right angle. Is a right triangle.
Mm-hmm.
All right. And then CD is an altitude. Now, here's the question. This is an interesting question. It says AD, so this part right here is 2,
Okay.
and this part down here is 8.
Okay.
Now, here's the hard part. It says find the perimeter of triangle ABC. So we want the perimeter of that big one. Now, we know what perimeter means, right?
Yeah.
Okay. So perimeter means distance around.
Right.
So we've got not very much information. We know that this is a right triangle because the right angle there. We know that this is a right triangle and the big triangle is a right angle. So what kind of relationship do you think the altitude here has to this big side?
Wouldn't it be one of the side angles? Like, can't we determine one of those side angles?
Okay, how are you going to do that?
I don't know. I just feel like we should.
This side, we don't know any angle except the right angle.
Okay.
Okay. We know the length of this side, of that side, and of course, obviously the whole length.
Mm-hmm.
Okay, so now I'm going to short circuit us a little bit, and this is a little bit of an obscure theorem, but it basically says that these two triangles, this triangle and this triangle, because it's an altitude, these are proportional.
Okay.
So if these are proportional, then this short side, and if I look at sides, then obviously this is the hypotenuse, right?
Right.
This is the short side, this is the long side. Now in this triangle, this is the hypotenuse, this is the short side, and that's the long side. So we can do a proportion that says 2 is to X. I'm gonna call this X right here.
Okay.
As X is to 8.
Okay.
So that's a thing that we just know from geometry, okay?
Okay.
Now when we do that, we get X squared is equal to 16, or X is equal to 4. So we know that this is 4 now.
Okay.
So if we know this is 4, can we find this side down here?
Yeah, because of Pythagorean theorem.
Right. Okay. So this is 4 squared plus 8 squared is equal to the length of CB. Got it?
Okay.
So 16 plus 64 is equal to CB, or wait a minute, CB squared. Catch me. So this adds up to be 80, right?
Yes.
So CB then turns out to be the square root of 80. And 80 is 16 times 5. So that's the same thing as 4 times the square root of 5. Now, did I lose you?
No.
Okay. So this side is 4 times the square root of 5.
Okay.
Now, do you think I could use this stuff and find the length of this side?
Well, if you're doing the proportions, you can now use that information.
Okay, so this is 2, this is 4. So AC now, how high can I write?
Yeah, you're good. I can see that.
Okay. AC squared then is 2 squared plus 4 squared. So this side squared because this is your right angle.
Okay.
Got it?
Which is square root of 20.
Okay, so that's the square root of 20, which is the same thing as 2 times the square root of 5.
Okay.
So
then we can fill that information in.
So we find out if we want this, then the perimeter then becomes the square root of 4 times the square root of 5 plus 2 times the square root of 5 plus 10. Or you could write that then perimeter is 2, 4, and 2 is 6 times the square root of 5 plus 10. Now, that's a little bit of doing.
Yeah.
But the trick to all that doing is remembering that this relationship between these two similar triangles.
Okay, so we have people who are wanting to get in.
Okay.
Do you know how to send them a link? Because none of them have gotten a link for today.
I have no idea how to do that.
I want to say because Blake's trying to get in and Alyssa's trying to get in.
Okay. Let's. He set this up for me, and
Like I don't think I have the option to add anyone.
all right. Let's see. Here's something that says links. Let me try this.
If you can send that to me, I can forward it to them. I know it's so confusing.
Well, he set it up and left, and so let's see. All right, let me see if I can call him real quick. Maybe you can
Okay,
tell me.
I'm sorry.
That's okay. That's okay. We can do it.
Where-
Hey, I've got some other folks that want to get in. How do I get them in or let them in? Blake and Melissa. Who else is it? Blake and
Alyssa.
Alyssa. Yeah. Oh, okay. I see it. The plus isn't doing anything. person. Well, I see something with a plus. It looks like it's got a clock in it, but I don't see a person. Oh, no. Or maybe it's that. No.
A few things along the top there that are like, there's the one where it's got the video camera and the microphone. Just on the screen, it should be like right above your head on the picture of.
No, that doesn't have any. There's not any of that on there.
On the window where the Google Hangouts happens.
Okay.
Kind of run the cursor back and forth and see if it pops up on top.
Oh, there it is. All right. Yeah, there it is. All right.
And there should be a person one looks like plus.
Yeah, that's all right. Let me get. All right, there we go. Send an invite, add names or add email. So add it. So I want add names. Do we have?
And you may want to try Kayla too, because I know she wanted on the last one.
Okay. Let's see. Blake is not Blake, but he's Leslie.
Yes, Leslie.
All right.
And then Alyssa's almost off work, so she'll be able to jump on if you send her something.
All right. Alyssa, A-L what? A-L-Y?
Hey, tell him he never sent an email with the link this time, or maybe it didn't go out. Okay, Blake said he's on standby, so he's ready.
Alyssa Hatch, is that right?
Yes.
Hatch. Okay. So I sent those.
And then Kayla Richardson.
Okay.
And then I don't know if Gabby's getting on or not.
All right. It says invitations posted. Okay. I sent them. So, okay. I sent the invitations. Now what I do? Okay. Well, tell Blake he's supposed to join it from.
Yeah, I'm telling him right now.
Mama.
Now this is on Google Hangout, right?
Yeah.
Yeah, okay. I'm going to tell him to open his Google Hangout. Hey, Jace, if you need something, go ask Daddy, okay, baby?
Okay. All right. Well, let's see. Okay. All right. There's something's popped up here. It says rescue time, offline time.
Is this mine?
I don't know, Jace. Please go with Daddy.
How do I do that? Don't log in at this time or more options. All right. Okay.
Sorry about that.
Yeah. Well, it's because somebody knew what they were doing.
Apparently not the case. sorry. I didn't have it.
All right.
Hey, Dr. Watson, is there any way you can email me the link and then I can give it to them?
Well, there's it.
Go on and I'll see if I can
Oh, okay. Okay. All right. All right.
help with.
Okay. All right.
Yeah.
Yeah. Okay. So here's what we're going to do. He's at home. He's going to get on his computer at home and see if he can
Uh-oh.
bring him in. And I'm going to go ahead and do another problem too while he's trying to do that.
Okay, and Blake said, did you send it to his Cub account?
I have no idea. I just sent it to Blake.
Okay.
But it's
He's gonna keep trying, so
the only one that's on here for Leslie Wiley.
okay. I said it's the one that he sent it to last time, probably.
Probably. All right, so Dr. Abel's going to go try to get on and see if he can bring folks on, and I'm gonna go ahead and we're going to talk math for a little bit.
Okay, keep going.
All right, are we done with that one? Okay,
Yes.
that one's a little convoluted, but believe it or not, that was one of the problems in the practice. Okay, here we go. So we've got a circle here. Flat on one side, looks like. And we've got O is the center here. And it says the area of this sector. Now this is called a sector because it starts at 0 and it includes this whole part here.
Okay.
So area of this sector is 24 pi square inches. Okay.
Okay.
Now it says if the diameter of the circle is 16 inches, then find the measure of the central angle of the sector. So we want to know this angle right here of
Okay.
this sector.
Okay.
So we've got a couple of things going here. We've got area,
Okay.
and then we've got the whole diameter. Now, what do you think we could do in order to look at this central angle here and find that measure? Any ideas?
The only thing I can think is maybe extend the line all the way across the circle.
Okay, it always helps to get a diameter. And this whole thing is 16, and so
Right.
it means the radius is 8.
Right. That was my next thing.
All right, so we know that part. So if we know the radius of a circle,
Mhm.
can we find the area of a circle?
Yes.
So the area,
Is pi r squared, right?
yeah. So if the radius is 8, then that's pi times 8 square, or 64 pi.
Okay.
Okay? So if I know then the area of the whole circle is 64 pi, and the area of this little sector right there is 24 pi.
Okay. So then we can Okay, go ahead, Dr. Abel. Do you need to do something?
No, I tried to share I was just going to let you know that I shared the link via email with some other folks, so they might be joining shortly. Hopefully that'll work.
Okay, thank you so much.
All
Certainly.
right.
Okay, so then can we divide 64 pi by 24 pi?
Yeah, we can do that, but now let's stop and think a minute. All right, this is 24, the whole thing's 64.
Mm-hmm.
What if, whoop, this is 64. No, that's right. What if we looked at the if we could find the ratio of the area of this to the area of that, then we could find the ratio of this part to the whole circle, right?
Right.
Know that the whole circle has 360 degrees, right?
Okay.
Now, what percentage part is this of the whole circle?
Well, it's only 24 of it
Well, it's 24
over 64, right?
64. There you go. So the ratio is 24 pi over 64 pi. So what?
Sorry, I'm just taking notes. Let me
Okay, now, if this is the ratio of the area of that to the whole circle,
it's 3/8.
we've got 360 degrees in this, and so we need to know how many degrees are up there, right?
Okay.
So pi is divided, and so the proportion says 64 times x is equal to 24 times 360.
24 times 360 is 8640.
Divided by 64.
And then divided by 64 is 135.
All right, so 135 then is the number of degrees in that angle.
Well, I be darned. Okay.
So
Well,
a little bit around the circle, a little bit of a relationship between area and this whole thing, the ratio of area and the degrees at the circle.
Okay.
So,
I like that one.
yep, that's kind of fun. I enjoyed doing that one. All right, let's see what else we can come up with. All right, here's another one that's kind of fun.
So Blake said that the link says it's no longer valid. So he can't get in.
Time he can watch it later. Okay, so we've got a quadrilateral built in here,
Okay.
and we've got A, B, C, and D. Okay,
Okay.
and this quadrilateral is inscribed in the circle. And then it says if measure of angle BAD, so this angle right here,
Uh-huh.
80 degrees.
Okay.
And the measure of BDC means that we're going to draw a line across there. The measure of that angle is 47 degrees.
Okay.
So we want to use that and see if we can find ADB. ADB, this angle right here.
Okay.
Now, this uses a theorem of circles where you look at an inscribed angle in a circle.
Mm-hmm.
Okay, so DAB is an inscribed angle, right?
Right.
Okay, so the theorem says that the measure of the angle of an inscribed angle is 1/2 the measure of the arc that it cuts off.
Okay.
So, what arc does that cut off? That arc right there, right?
Right.
So how big is that red arc now?
Isn't it 360? Oh, it's so you said it's double. So it's
double this, so it's going to be 160, right?
right. Okay.
That makes sense?
Yes.
All right, now, what else can we find out?
Hang on. I'm trying to write all this down. So it's equal to 160. Okay. Well, then the other half's going to be 160,
There
right?
you go. Then the other half is, how big is this then?
Wait, hang on. So
Oh,
that
wait,
one.
160. This whole thing is 160. Now look at this angle here. It does the same thing, doesn't it? Doesn't it cut off this arc?
Oh, so that would be double 47,
Right. Which is
94.
94. So if this whole thing is 160 and that part's 94, then that makes how much for this one?
So 160 minus 94 is 66. So arc DC is 66.
No, no. Yes, that's correct. Now, how can we use that information to find anything about that angle?
Okay, well then DBC is going to be half of 66, so 33. And then that triangle makes 180. So 180 minus 47 minus 33 is 100. So DCB is going to be 100.
Okay, good.
And then we can use that information. Well, we know that a quadrilateral has 360 degrees. So we need to find two more angles.
I failed to tell you one other piece of givens.
Oh, well, this might help.
All right, and it was the line segment DB bisects angle ABC.
ABC. Okay, so then it's going to cut it in half.
Yep. So that makes that one 33 too, right?
Okay, so then we do 360 minus all of the above. Minus 180 minus 33 minus 80. And so that angle is going to be 67.
You're right.
Boom.
Boom.
Math. I like that one too.
Yep, those are fun.
Yeah. Okay.
Any question about the logic that went into that?
No. I followed.
Okay, good. All right, now here's one that's got a little bit of trig in it.
Okay.
I know this is not trig, but this is, we'll see if we can remember some of these same little theorems that we've been playing with. All right, we've got all right, this is a right angle.
Okay.
All right. The radius of this circle is 5. And so,
Go
so
ahead.
if we put an X right there, Is there anything that we can,
The only thing that I'm seeing is
all right, one other piece of information. That arc right here is 70 degrees.
okay. Well, I'm wanting to play with Pythagorean, I'm guessing, because we know that you said the radius is 5, so the diameter is going to be 10, which that's the hypotenuse.
Right.
So I guess I'm trying to figure out where to go from there. And then x squared.
Can we use this to figure out one of the angles?
Well, we can use what we did earlier.
All right. So if that arc is 70, what does that do to this angle down here?
So that's half of 70.
Right.
So 35.
35.
Well, and then we know that from the top of the triangle to the bottom of the triangle is 180. So 180 minus 70 is 110.
Or here.
Yeah. And then that other angle would be half of that, which is 55.
All right. But that
And so
hadn't helped.
now,
That hadn't helped us with the X yet. We know what all the angles are. Can we do a trig, use a piece of trig to find the length of that side?
wouldn't we have to have another angle to use, or another side to use SOHCAHTOA?
Well, we've got it, don't we? Because in this whole part here is what?
10.
All right. So if I take this angle, this side's the hypotenuse, right?
Yeah.
All right. And this is the side adjacent.
Oh, okay.
So what is the trig function that has the side adjacent and the hypotenuse?
Cosine.
Okay.
So the cosine of 35 degrees equals
Cosine of 35.
equals 10 over x.
X over 10, isn't it?
Oh yeah, I'm sorry.
Adjacent divided by
Yeah,
the.
yeah.
So use your calculator and do cosine of 35.
How do I hang on? It's supposed to be in radian or degrees. Okay, it's
It
degrees.
should be in degrees.
Okay. So then I do cosine of 35
No,
over 10.
no,
Or no, times 10.
multiply by 10.
So it's 8.19.
Okay.
Okay. And then are we supposed to find the other side or does it matter?
No, I just said to find that one side.
Okay.
But once we know this side, then we could go in there and find the other side.
Right. So
Pythagoras.
one of the options was 8.2.
Well, you could either go back in there and do sine, or you could do, well, now that we've got this one, you could do the Pythagorean theorem and do it.
No, I'm talking about for x. The answer that we just got, is that one of the
8 points.
Okay, so that was one of the multiple choice answers.
Yeah.
Okay. Okay.
That makes sense.
Yes.
All right. Let's get away from circles for a minute.
Okay.
Here's kind of a weird looking figure.
Yeah. Okay. I'm gonna be eating this go round if that's okay with you.
Okay.
Is this proportions also?
No. Okay, so we've got 64, 71, 62, and 72.
Okay.
Whoops, 78.
Okay, well, the first thing I would do is finish off that first triangle.
So we want to know what the measure of that is.
Okay, well, we first need to finish off the first triangle. So 180 minus 64 minus 71 is 45. So right there beside that 62. So
Okay.
then we know that that whole line right there is going to be 180 also.
Right?
So 180 minus 45 minus 62 is 73.
All right.
And then we just finish off the triangle. Is it that easy?
Yep, that one's easy.
Oh, wow. Okay.
29.
So 29.
Yep.
Yay. I'm sorry. I should have let you talk through that one.
No, this is you to talk, not me. All right, here's well, that one's still circles. Let me see if I can find another one that's not a circle.
I guess I'm better at geometry than I thought.
Ah,
I said, I guess I'm better at geometry than I thought.
yeah, you are. It's just, the few little things hanging out there. But the big part of it is, being able to read the question and being able to find what information that you have that applies to it.
Right.
Okay, so here we have a semicircle. All right, and then added onto this semicircle, this is not a continuation of the circle, but it's a straight line. And there's a triangle that's out there.
Okay.
Now, this little segment of the triangle is 1 centimeter. The radius of this semicircle is 1 centimeter.
I guess it's not drawn to scale.
I guess not. That's all. You can't solve a geometry problem with saying, okay, it looks like.
Right.
Now, what we want to know is, it says the figure above consists of a semicircle of radius 1 and an attached right triangle with one leg equal to the radius of the semicircle as shown. All right, what is the figure's perimeter to the nearest 10? Now, we're looking at the perimeter then of this whole thing, which takes the outside here, and then it includes the triangle. So we're looking for the perimeter of all that.
Okay. So my instant thought is, so each of them is 1 centimeter and 1 centimeter. So we know that the hypotenuse, since it's a right triangle, we know that the hypotenuse is going to be the square root of 2.
Be careful.
Wait.
All right, now this whole thing, it said the radius was 1, so the diameter of that's not 1. And what is it?
Oh, it's 2. Oh, okay. Hang on.
2.
The
Right.
square root of 3.
All right, so if this is 1, here again, be careful, because the square root of 3 applies to a 30, 60, 90, and that means that the hypotenuse is twice the short side, not the long side.
Oh, okay.
Be careful. But what you can do is use the Pythagorean theorem, right?
Okay.
So you've got 1 square plus 2 square is equal to that hypotenuse square.
Third.
The hypotenuse then is equal to 5
It'll be the square root of 5.
square root of 5. You're exactly right.
Okay.
Okay. We got that sucker down. We know this. So all thing we got left to do now is to find the distance around the outside of this semicircle.
Well, we know it's 180 degrees,
Okay.
but I don't know if that helps us.
What? All right. If I'm trying to find the distance around, what's another name for distance around in geometry in a circle?
I don't know.
Circumference.
Oh. Yes, that word.
That work?
Yes.
Okay. So what's the formula for the circumference of a circle?
I have no idea.
All right. It's pi times the diameter, or pi times 2r.
Okay. So then we have
So the circle then is pi times 2, or 2 pi, right?
Yes.
Okay.
So then we have 2 pi plus 1 centimeter plus.
No way. Now that's the circumference of the whole circle,
Oh, so we have half of that.
like half of that. So the circumference of half of it then is going to be what?
Just pi.
Pi. So if I take all of this part and then this part and up here, then I have pi plus 1 plus the square root of 5.
Oh. Okay.
Right?
Yeah. Is there a shorter way to write that?
Well, actually not. Well, you could do this if you, and this is one that it's instead of multiple choice, it's open ended. So you could do pi is 3.17 plus 1 plus the square root of 5. So you can combine this and do 4.17 plus the square root of 5. And if you want to go ahead and get a full decimal answer, then you could do 4.17.
Isn't it 3.14?
Yeah. 3 1/7 is 3.14. You're right. That's 4.14. And then the square root of 5 is 2.2, something like that.
The final answer is 6.38 or 6.4.
Okay. There you go.
Oh, okay. Okay. I just didn't know if since you said it was open response, do we end with the pi plus 1 plus square root of 5, or do we just call it safe and go all the way?
Yeah, you kind of get counted off for it because it said to give your answer to the nearest tenth of a centimeter.
Oh, okay.
They want you to do that.
Okay.
Agree?
Yep, we're good.
You, all right, let's see what. Here's another circle one, but I'm telling you, seems like the authors of these tests really like circles. Now, we got a circle and we have a rectangle that's built inside this circle.
Okay. Wait, a rectangle or a quadrilateral?
Well, it's actually, it's going to turn out to be a square. when I read the rest of the problem. All right, in the figure above, the circumscribed circle about this square, all right, has a circumference of 8 pi centimeters. So the circumference equals 8 pi. Now that's the distance around the circle.
Okay.
Find the area of the square. Find the area of this thing.
Okay.
So I'm gonna draw some more in here. I'm gonna erase this mess. Now we know what we're talking about. All right, this is a square, and I draw this. Then this
Then
is
the
a right.
diagonals bisect each other,
This becomes a diameter, right?
right?
Okay. Now, if this becomes a diameter and this is a right angle and these are square, so this side and this side are equal, right?
Right.
This side and this side are equal.
Okay.
Now, if that's the case, how big is this angle right here?
Hang on, I'm still catching up on notes.
Okay.
Okay, well, if that one's 45, then it's 180.
All right. You're right. This is 45. This is 40. Now,
When
we know the circumference now is 8 pi. Can that help us find the diameter or the radius?
wait, what are we looking for again? The diameter?
We're looking for the area inside here.
Oh yeah.
But don't I need to know something about how long that diameter is or the radius is?
Yes. I'm super lost.
Okay. Where'd I lose you?
I don't know. Like is that wouldn't it where you put diameter, wouldn't that whole thing right there be 45 degrees or 90 degrees? Okay, never mind. I get you now.
This is right here, yeah.
Yeah, okay, I'm sorry. I get you now.
This is 45. You agree?
Yeah.
Okay, so now you didn't remember this while ago. Let's see if you remembered it now. What's the formula for the circumference of a circle?
2 pi r.
2 pi r. Okay, so if I know this is 8 pi, and that's equal to 2 pi r,
So we divide by 2
r then is equal to what?
4. Oh my gosh.
All right, so this is 4, right?
So then the diameter is 8.
The diameter is 8.
Hang on, I'm still writing stuff down.
Now, what happens? I draw a little line right there.
Well, it'd be 45 degrees.
All right, and how big is that? 4?
Yeah.
So can I use that then to figure out how big this side is here?
Well, yeah, it'd be
These are 45, right?
16 plus
so-
16.
So this is a 45, 45 right triangle.
Yeah, and that one's going to be the square root of 32.
How'd you get that?
4 squared plus 4 squared.
Oh, okay.
Right?
Yeah, yeah.
But we don't, do we need that?
I was doing an easier way. Well, if we do it, if it's the square root of 32 and simplify that, then that's 4 times the square root of 2, right?
Mm-hmm.
All right, but if we know this is an isosceles right triangle, then the diameter is always the square root of 2 times a leg. And so that's just going to be the square root of 2, 4 times the square root of 2.
Okay.
You got it either way.
Okay.
So how does that help?
I have no idea. That's what I was going to ask you.
Well, this is a square, right?
Right.
How do you find the area of a square?
The area of a square. Didn't we do that one earlier?
I don't think so. If I just have a simple square out here,
I can't remember the formula.
well, if this is a side,
Oh, it's length times width.
right, and this is side too, so it's side square, right?
Right.
All right, so if this side here is 4 times the square root of 2, then 4 times the square root of 2
Square.
then is 16 times 2, 32.
Hang on, I'm trying to put it in the calculator and make it easy.
Okay,
32.
yep. So the area of this mess here in the middle is 32 square inches. Yeah.
That one was more difficult. I don't like that one.
Okay. Let's do one more, and then let me find a good one. Let's see if I can get one that doesn't involve a circle.
You have to get through over 3 tracks. There you go.
Do you happen to know what the topic for next week is?
I do not.
Okay.
Todd's doing that, and
Okay. I know he said Dr. Martin might come in.
oh, okay. So that'll probably be something in calculus then.
Okay, and I'll talk to Dr. Abel about some subjects I want to look at.
Okay. Is this helping any at all?
Yes, definitely. Because me and geometry are not friends.
Okay. Regular hexagon.
It's okay. It doesn't have to be perfect.
Regular hexagon, 6 sides, right?
Yes.
The distance from the center of a regular hexagon to a midpoint of a side of that hexagon has a length of 4.
Okay.
Now, it says find the circumference of the circle that circumscribes the hexagon.
Okay.
Now, I said I would try to find something besides a circle. I must
It's okay.
talk about I did, but I didn't. Okay. But anyway, this is supposed to touch at all these corners. Can you imagine that?
Yes.
Okay. So what on earth could we do?
Well, we know the diameter is going to be 8.
Be careful.
Wait, I thought it was double.
Well, but this is not the diameter of the circle
Oh.
because it doesn't go all the way to the circle.
Okay, okay, okay.
If we could find that, it would be. This thing right here is 8, but not the diameter.
Okay.
Okay.
Can we do the
Let's-
art?
Yes, I bet we could. So if this is 6-sided, then how big is that sector right there?
OMG, I don't know.
Yeah, you do.
Hang on. 8 doubled 16.
No, not quite. This is not the measure of that angle now. This is the
Oh,
this length
dang it,
right
that's the radius.
All right. How many of these little sectors are all if I went all the way around, would there be?
1, 2, 3, 4, 5, 6.
6 is correct.
Duh.
This is 1/6 of the area of the circle, right?
Okay.
This is 1/6 of the circumference of the circle.
So 1/6 of 180
Yes.
is, whoa, that's not right.
No, it's 1/6 of 3. Excuse me, of 360.
Oh, I'm sorry, 360. 60.
Right. So this is 60. The length of this arc.
Okay.
Now that makes this central angle right here. How much?
30.
No, that's all right. You're getting two things confused.
I thought it was half.
This is the inscribed angle. If this is 60, then this angle over here is 30. All right, a central angle goes from the center of the circle out here, and that has the same measure as the arc.
What? I don't think I've ever heard that in my life.
Oh,
Okay, I'm just gonna shut up and listen to this one.
sure. All right, think it through.
Okay.
All right, this is called a central angle.
Okay.
It has the same measure as the arc it's inscribed.
Okay.
This is an inscribed angle, and it's 1/2 of the arc
Right.
that it inscribes, which we did earlier.
Okay.
So, now if we know that this deposit hits this at a right angle, and we know this little side right here is 4, and we know that this whole big angle is 60, and that divides that, then how big is that little angle right there?
Just keep going.
Okay.
Dr. Watson.
This divides this in half, right?
Right.
So if this whole thing is 60, how big is this little angle?
30.
All right, so that means this angle right here is 30, right?
Okay.
Now, if this is 30 and this is 90, how big is that?
60, 90 minus what? I'm sorry, what was the question? 60, 30.
All right, this angle is 90.
Okay.
This one right here is 30. So how big does this one have to be?
Oh, so 180 minus 45 minus 30.
It's 60. Because it's 90 plus 30 minus 180.
Oh, it's an, okay,
This
yeah.
This turns out to be a 30, 60, 90 right triangle.
Okay, okay.
Now, in this right triangle, then this is the long side, this is the short side, and this is the hypotenuse. But this part here, the hypotenuse, we already know what it is. It's 4.
Okay.
Because it's a radius. Okay?
Okay. I forgot what the original question
Well,
was.
I didn't.
I think it's
All right. Find the circumference. Oh, we want to find the circumference of the circle.
okay. Well, we know the circumference of a circle,
The circumference of the circle is
2 pi r.
r. All right. So now if we can find some of these things, if we could find the circumference of this part here, then we could, since we know that this is 1/6 of the whole circle, then we could just multiply that by 6, right?
Okay.
All right, so in a 30, 60, 90 right triangle, let's draw it out here. All right, this is part we know is 4.
Mm-hmm.
All right, so this is 30, 60, 90 right triangle. So what do we know about the short side in relationship to the hypotenuse in a 30, 60, 90 right triangle?
They're equivalent.
No, not quite.
Well, I mean, we could use SOHCAHTOA in this.
Yeah. You want to do that? We could do that.
Well, I mean, that's the way that I would go about it because I don't know the route that you're going. So if you want to explain your route.
Okay. All right.
Because I'm thinking.
Okay. If I want to do this, I can take the sine of 30 degrees here.
Yeah.
And I can do the opposite over the hypotenuse, and I can find.
So sine of 30 times 4 is 2.
Okay. So that makes that 2. Oh,
Well,
yeah.
then now you can do Pythagorean theorem.
Yeah. So that's. Okay. I've got too much mess up here.
It's okay. I'm trying to figure out the answer.
Okay.
So x is the square root of 12, which is 3.
Okay. So if we did the. All right, so we need to find the length of the hypotenuse. So if we take this side, we can go cosine of 30 is equal to the adjacent, which is 4 divided by the hypotenuse. So this is 4 divided by that. So the hypotenuse then is equal to 4 divided by cosine of 30.
4 divided by 4.6.
Okay.
Wouldn't it be 4 times? No, never mind. You're right.
Yeah, if we go back to to our unit circle, and we leave it in terms of pi. We can put those numbers in there, I guess. So what'd you say, 4.6?
Yeah.
All right, 4.6. So that says that this is 4.6. Now that's the radius. So now we have the radius, and we can slip that back into this circumference equals 2 pi times the radius,
Yeah.
and get the circumference.
When you just do 2 times the 4.6.
Times pi.
So they wanted it
Oh,
in non-pi.
yeah, we just leave it in pi. Yeah.
It was 9.2 pi.
So 9.25 times pi. Okay. That works.
Okay.
All right. Sorry, I kind of got you messed up on.
No, that's okay. I was confused on that one too.
Yeah. Okay. So we've done mostly a lot of circles, but we've done some other stuff. So are you okay with what we've done?
Yes, I feel a little bit better about that one.
No, yeah, because geometry, there's not that much geometry, but it's just enough to cause you to not do well sometimes when you don't know
Was
something.
that one an open response one too?
No, that was a multiple choice one. So,
Okay.
but anyway.
All right. Well, thank you so much.
Okay. All right. Well, good luck. I'm sorry we didn't get the others on, but we can.
That's okay. We got next time.
All right. Okay.